Hi guys, for today's lesson we're going to be dealing with similar triangles. So some rules to remember are that similar to congruent triangles, there are four sets of conditions or tests that are enough to demonstrate that two triangles are similar. So like congruent triangles had their own four tests which prove whether two triangles are congruent. There's a very similar thing with similar triangles. They also have their own four tests. So when triangles are similar, remember that they have matching angles, or their matching angles are equal, and matching side lengths are in proportion. That means they have equal scale factor. So test one to show that two triangles are similar. So how can we show that these two triangles are similar? Well, if all sides are in proportion, that means that they are definitely similar. And the way to show that is to show that pretty much you want to pair up these sides which are matching, and you want to find the scale factor for each one. So 6 over 3 will give you your first scale factor. 6 over 3 is equal to 2. We've got 10 over 5, that's also equal to 2, and 8 over 4 is also equal to 2. So they all have a scale factor of this 2 here. So therefore they are all in proportion. They are similar. It's very similar to side, side, side for congruent triangles. Test 2. So that is when you have two pairs of sides that are in proportion and the included angle is equal. So this is similar to SAS. And this sort of triangles show that one. So we've got these two sides which have a scale factor of 1.5, as you can see here, 9 over 6. And these two sides, 6 over 4, they pair up and they give you the same scale factor. Because they have the same scale factor, that means they are in proportion. And we can also see that our included angle is equal, so that's enough to satisfy test 2. These triangles are definitely similar. Test 3, two equal angle pairs. This is similar to angle side, but not including this S. So it's pretty much just like angle AA. So if you have two pairs of angles which are equal, that's enough to prove that these triangles are similar, because they pretty much have all the same angles, and that's the definition of two shapes which are single, all the same angles. Next up is test 4. This is a bit of a mouthful one. So the hypotenuses and a pair of sides are in proportion in two right angle triangles. So when we're dealing with this one, you need right angle triangles, and you have your hypotenuses in proportion with another pair of sides. So you can see here that both of these scale factors are 3/4, so so the sides are in proportion, and they're both containing a right angle. So that's enough for test 4. Okay, so let's do some example questions. So for each pair of triangles, determine whether they are similar or not, and then state the reasoning for the similarity. So if you look at these two triangles here, we've given you all the side lengths, so that suggests that we're going to be using test 1, which is similar to side, side, side. But we need to follow this strategy. We need to check whether each pair of sides has the same scale factor, because that determines whether they are in proportion or not. So first up, 3 centimeters goes with 6 centimeters, so that's a scale factor of 0.5. Next up is 4 goes with 8, so that's a scale factor of 0.5 as well. So these two sets of sides are in proportion. The next one is 6 centimeters goes with 11 centimeters, and that is not in proportion. So that suggests that because this pair of sides does not have the same scale factor as these ones, therefore the sides are not in proportion, so therefore the triangles are not similar. And the reason for that is because the side lengths are not all in proportion, unequal scale factors. Okay, moving on. So now we've got these two triangles here. We've got given lots of information about both triangles. If we look at our side lengths, we've got 20, 9, and 16. That's enough to show one pair of sides, so we can find a scale factor there, but we can't compare that with another pair of sides. We've only got 3 sides given to us. So the 3 sides is not going to be enough information to show that sides are in proportion, but we do have enough information with our angles. We've got a pair of angles there the same, and we've got another pair here. So that satisfies test 3, that the triangles are similar, and the reason is because there's 2 equal pairs of interior angles. Test 3. I hope this helps with the questions. Good luck.